patterns. What are the other two congruence patterns for triangles? Do you guys remember from geometry? SAS is one, and then the other one is SSS. Good. Mr. Dobler is going to be very pleased to hear you guys remembered that information. Yeah, Tom. I will also tell him and says hi. I will tell him that you guys all say hi, with the exception of, I'll just pick one of you to say didn't like him. So. All right, so, is Alex okay? What do you say? Okay, so the law of cosines can be used for these two patterns. Okay, so when you're looking at triangles, okay, where you have these A, B, and C opposite the angles A, B, and C, if I gave you, let's say, this angle, this side, and this side, okay, what pattern does this given information fit? It's two sides in the included angle. So that's SAS. You would use law of cosines. What if instead of this side here, I gave you this side? What pattern is fulfilled here? You have two sides. Okay, so it's either SAS or SSA. Is the angle between these two sides? No, it's opposite one, so it's going to be SSA. So you'll use law of sines. In fact, how many different triangles would you anticipate finding for this figure based on SSA? Remember, SSA can either be one or two triangles. Why two? Sam? You're right. Do you remember how you find that out? If we look at the side that's opposite the given angle here and assume that it's on a hinge, if we hinge this so that this side was 8 as well, forming an obtuse triangle here, would it make sense that opposite that obtuse angle is the side of 10 when the other side is 8? Yeah, the opposite side, or the side opposite the largest angle has to be largest, so as long as this fits, you're okay. And now, what if my angle was up here? It's still SSA, it's still the SSA pattern, but now would it be one or two triangles? Here it's just going to be one, because again, if we imagine this kind of hinging at C and forming our other triangle here, where this would be a length of 10, could this side here be 10 when you know that this is your obtuse angle right here, and the side opposite that is 8? No. Okay, so again, using that, you can identify that information. What if I gave you, instead of this angle, I told you you have sides of 7, 8, and 10? What pattern would you use? SSS, which is law of cosines. Okay, so you need to be able to distinguish which pattern of information is being presented. In the homework here, they'll start by giving you specific ones where the law of sines is, or law of cosines is always used. Then they're going to give you a couple questions where you have to choose one of them. And when you guys do your quizzes and tests for this chapter, which I think we'll just have a test left for this, you need to be able to identify on your own which of the patterns is used. Okay, here's what the law of cosines, or how the law of cosines is written. Okay, it says that the square of any side is equal to the sum of the squares of the other two sides. What's this based off? Pythagorean theorem, with a slight adjustment. Okay, when it's a non-right triangle, there's an adjustment to this, and the adjustment is minus twice the product of those other two sides. So the ones away from the side that's isolated on the left here. So minus 2bc all times the cosine of the angle that's opposite this side. So what angle is opposite side A? Capital A, right? Okay, so this is one way to write the law of cosines. Okay, there's three different ways to write it, all depending on which side you want to isolate. So what if the side we isolate is B? Then B squared is equal to the sum of the squares of the other two sides, minus twice the product of those sides, times the cosine of the angle opposite B, which is B. And then the final possibility, C squared is equal to A squared plus B squared, minus twice AB all times the cosine of C. Okay, now, in order to determine which of these forms you use, what you have to do is you have to look at these pieces of information. Okay, the ones that match up with the angle. And so it's either a given or unknown angle and the side opposite that. Okay, so I'm going to show you here in just a moment how to choose what those are. But you're using these outside pieces of information. Okay, and so your question is still going to be solve this triangle, which means find all the missing pieces. So you're going to find angle A or angle B, C, and side A. Okay, so first of all, what pattern's used for this? Two sides in the included angle. So SAS is law of cosines. And so what you're going to do is, again, everything's based on the angle being involved here. Because remember, in this, you're either going to be given one angle, in the case of SAS, or you're going to be given no angles. If you're given one angle, that angle is the key to how you set this up. So the angle that we have is angle A here. So that means that we start with the side opposite that. So the equation that we choose here is A squared is equal to the sum of the squares of the other two sides. So 11 squared plus 18 squared minus twice the product of those two sides, all times the cosine of that angle, 58 degrees. Okay, so if I had been, depending on which information's given, you're simply going to use or begin with side opposite that known or given angle. Okay, the way that this is set up, because we're solving for a side here, easiest thing to do is just use the solve feature of the calculator. So if we enter solve, type in that whole thing, I'm just going to use, again, an x here. X squared is equal to, and then just type the entire thing that I have, 11 squared plus 18 squared minus 2 times 11 times 18 times the cosine of 58. Guys, quiet, please. Okay, and then solve for x. Okay, make sure you're in degree mode since we're working with angle measures in degrees. And when I hit enter, I get my answer. Well, there's two solutions, right? Anytime you're solving quadratic equations, you're going to get two solutions or a repeated solution. So here we have negative 15, which can that be the length of this side A? No. And the other one would be the positive of that. So A is equal to about 15.3. Okay. So now I found one piece of information. Okay. In order to find angles B and C, what do you think I need to use now? You can use law of cosines. We now have SSS, so we can use law of cosines pattern again. Or can we use law of sines now? Do we have SSA pattern once we find this side A? Yeah, we now have SSA as well. So you can use either of those. Law of sines is probably an easier calculation. So I'm going to use law of sines to find angle B here. So if I take angle B as my unknown, I set it up as sine of B over what? You set up your ratio of the sine of an angle over the side opposite that. So opposite B is 11. And that's going to equal the known ratio, sine of 58 over the measure we just found, 15.3. So if you recall, when we multiply this through, we can isolate our sine of B and calculate here, the sine of 58 times 11 divided by this 15.3. Again, I need to go up. Now, when I access this, I can't do the copy and paste on this, but you guys, because I can't hold two buttons at once, but if you are using a hand calculator, remember you can copy and paste by holding this up arrow key. go to the end of the number you want to copy, hit up arrow, and then use the cursors to move to where you want it to end, and then just hit the copy and then the paste. What I'm going to have to do here is I'm going to have to enter this separately. So this is the way I'm going to enter it. I'm just going to enter that whole value here, and then I need to delete everything that's not involved. And so I'm able to still get my value. I can now hit enter. So here's my sine ratio is about 0.608. And what do I need to do in order to find angle B now? Now you use the inverse of that. So if we take the inverse sine of that ratio and hit enter, we get our angle measure to be about 37.5. Saber?
What does that say on the left, sine B?
Here, sine of B.
Okay.
Yeah. Right, once we find our angle B, what can we do to find angle C? We now have three options to find angle C. Okay. So one, we could do law of cosines, we have SSS. We could do law of sines, we have SSA. Or we could add up the angles, know that they add up to what? So if you take 180, subtract the 37, and then subtract this 58, you get your answer of 84.5 as your final. Okay, now, when we look at this, is this consistent with what you would expect based on the properties of a triangle? Is the shortest side opposite the smallest angle? The longest side opposite the largest angle? Yeah, so it's consistent with what you would expect.